You can make a note while we're getting ready and getting things out of what the assignments are for next week. So on Monday, we're going to take a quiz. It will be a show work quiz. I'm going to be grading all of the steps in the problem solving method that we're working on, that we started working on yesterday, and that we're going to continue working on today. So you need to be prepared for that. The only way to prepare for that is to do the practice assignment, which is pages 27 and 28 in your packet. All right, so page 27 and 28, I believe there are 8 questions that I want you to solve using the guess method and the check. So you're going to do the guess and the check for all 8 questions on pages 27 and 28 for Monday. As a reminder, your test corrections are due Tuesday. If you have those today, you stick them in the bin before you leave. You could do that during the break. And then the review assignment for this is also due Tuesday. That's pages 29 to 42, because this is the last section of the unit. You will take a test on accelerated motion, which includes constant velocity motion as well in there. Some old questions will show up on Wednesday's test, but the focus will be accelerated motion, not constant velocity. All right, any questions? All right, then let's go to our packet and let's continue where we left off yesterday, which is in problem 4. We got the substitution done, but we did not get to the final answer. So let me give you all a minute to calculate that out, and then we're going to start going around the room where everybody does a piece of the question. Since this is 0, this part will drop out. You don't even have to really think about it. What is that acceleration? With proper units, sig figs, and direction. Everybody a minute. I see a lot of you still typing it in. Alex, do you have it?
I got 2.5 times 10 to the 6.
No. So you're going to do 71 squared. I know what your issue is. You have to divide by both the 2 and the 1e3. You only divided by 2, and then you multiplied by 1e3. Okay, you have to surround that with parentheses if you want the calculator to divide by both things. So 71 squared divided by, and really, what is 2 times 1 times 10 to the 3rd power? It's 2 times 10 to the 3rd power. So I would just do 71 squared divided by 2e3, scientific notation. What did you get now? There you go. And what units?
Meters per second squared.
Good. And what's the direction of it? Because acceleration is a vector.
Positive.
Positive. There you go. Okay. Now we're going to do our check step on this because we have not checked this equation solved for A before. So let's do that over here. A equals VF squared minus VI squared over 2D. So Nick, what's the unit of VF? Good. So let's put meters per second there. Surround it with parentheses, and then we're going to square it. Nick Rennick, what's the unit for VI? Good. So we're going to square that quantity as well. In the denominator, we ignore the number 2 because that doesn't have a unit. This is only about units. Jules, what is the unit for D in the denominator? Meters. Okay, now we're going to do order of operations, which means we have to distribute the squares through these sets of parentheses. So, Caitlin, when I square a meter per second, what does that give me? Very good. So I have meters squared over second squared minus meters squared over second squared all over meters. Now remember that there are no numbers here. So this is not 0 in the numerator. It's basically saying you have some number of meters squared per second squared, and you're going to subtract another number of meters squared per second squared. So when you do that subtraction, what units, Addie, would you get on that final answer in the top? A number of meters squared per second squared minus another number of meters squared per second squared would be a number of what? Same thing. So meters squared per second squared, and then we divide by meters. Remember, this is all about showing how to get to the final answer with units. Jack, what happens now at this point? Because we got to clean it up. I don't have the final answer yet. Yep, so that square would cancel here. And what am I left with? Just 1 meter over the second squared. And that is what I expected. So that does check. But you have to show all those steps to get to the answer. That's what dimensional analysis is about. It's about showing each step to get to that. All right, let's go to number 5. And the way we're going to work these out now is by everybody doing a step of the question, including reading it. So Janelle, we're up to you. Could you read question 5 for us? That's the first step. All right, so as she read it, we should all be circling the measurements that were being given. Now, remember, this is an airplane, and yesterday we talked about something we know about airplanes before they take off. So that gives us an additional given. So now let's go to our givens list, which is the next step. Olivia, can you give me one of 3 givens that we're going to have for this question? That's right. That's the one that we have to just know because it's an airplane. Dakari, can you give me another given for this question? Is? Okay. Is meter per second squared a unit of velocity? It's an acceleration. So what is this? It's not final velocity. It's a, lowercase a. And Josh, what's our third and final given? So what letter do I write for that? Yeah, lowercase t. There is a capital T on the reference table elsewhere. That means something else. So make sure it is lowercase. All right, what is it that we're looking for, Fig? What letter? So what letter? Okay. Now we got to go to the reference table. And let's locate the equation from page 6. You have your reference tables in front of you, so you can check those out. It has to have V, I, A, T, and D in it. Pia, do you see an equation? That's right. And it is already isolated for the D, so there's no algebra to do. So now we can do our substitution with units. So the D is 0 meters per second times 32.8 seconds plus 1/2 of 3.20 meter per second squared times 32.8 seconds squared. Now, you can simplify your life a little bit here before you go to the calculator. Because what is 0 times 32.8? 0. So this part of the equation is going to drop out. Basically, from this point forward, ignore it. Let's now go ahead and solve that. We need an answer with units and sig figs. There will be no direction because distance is a scalar measurement. Emily, can you tell me what that distance would be? Make sure you square the time. I don't think you did on your calculator. That is, yeah, go ahead. How many? I'm sorry. Okay, half is not a measurement, so it doesn't have any sig figs. You just look at these two. Oh, yeah, and that doesn't have sig figs either. So you're just looking at these numbers here to tell you about your sig figs. So how many do you need? 3. Yeah, you got to have 3 sig figs on this answer. 1,080 meters per second squared. That has 2 sig figs. Or no, that has 3, but that's not the right answer. 1,080 would not be correct. Cam, what did you get?
1,072. Sorry, 1,720.
There you go. 1,720 meters. So Emily, when you do it on your calculator, that's what you should see. 1,721.344. So it's 0.5 times 3.20 times 32.8 squared.
Are you using the X or the
You don't need any parentheses. Just type in 0.5 for a half times 3.20 times 32.8 squared.
I'm still getting
0.5 times 3.2 plus 0.5 times 3.2 times 32.8 hours squared. So let's do the square first. 32.8 squared times 0.5 times 3.2. Okay, so just do the square first. The order of operations, we would do the exponents, right? Please excuse, do that's that type of calculator has to be done that way. Yeah.
For the Regents exam, are we going to be allowed to use this?
Yeah. Yep, we just clear the calculator memory first. All calculators get cleared first. So this is the final answer with our 3 sig figs. No direction on it because distance is a scalar. So the next step is to check it. I don't believe we've done a check on this equation yet, have we? We have in number 3. Yep. Okay. So let's just say the check is the same as number 3. I'm not going to repeat it for time's sake. Okay. If you can do it once, you should be able to do it every time. But that's the same as question 3's check. Same one. All right. Number 6. So where did we leave off? Cam, go ahead and read. Or no, you gave me the answer. So Purnima, read question 6 for us, please. Right. So as it's being read, you should be circling and underlining. Okay. Now we're going to go to our givens list. Ashley, can you give me one of the 3 givens for this problem? Okay. So lowercase t is 5.21 seconds. Savannah, another given, please. So D is 110 point meters. Alex, what's my third given?
VI equals 0 per second.
Good. Nick Rushford, what's my unknown letter? Lowercase a. All right, now we need the equation that has those letters using your reference table. Nick Rennick, do you see the equation that has those 4 letters? That's right. Now here's where things get a little tricky. The A is not isolated. We have to isolate the A. But we can simplify our life a little bit. Because what is the value of VI? Jules, can you tell me the value for VI? 0. So if I multiply the 0 by the time, what's going to happen to the first half of this equation on the right? It's going to cancel out. So let's just show it dropping out right now. It drops out because the VI is 0, which means that that equation can be simplified to D is 1/2 A t squared. And now you should be able to isolate the A pretty easily. So I'll give you a minute to do the algebra. I want to know, what is the equation for A going to look like? So you got to bring the half and the t squared to the other side. And they're both multiplying A at the same time. Caitlin, you want to take a stab at what that equation would be? Say that again.
A equals.
Okay, so how do you get a half to the other side? Is it being, what's happening between the half and the A right now? So what's opposite of multiplying? Division. So we're going to keep the D and we have to divide by the half. Now let's think about the T squared. What is T squared doing to A? So how do you get that to the other side? Also dividing. So we can divide by half and T squared at the same time. Now, let's think ahead a little bit because I don't like having two numbers in the denominator if we don't need them. When you divide by half, it's the same as multiplying by something. Multiplying by 2, right? The reciprocal of a half is the number 2. So this can really be the same as A is 2D over T squared. Dividing by a half is the same as multiplying by 2. And this will make your calculator work a lot nicer. Let's now go ahead and do our substitution with units. So A is 2 times 110 point meters over 5.21 seconds, and that quantity must get squared. Now we're going to go to the calculator and work that out with proper units, sig figs, and direction because acceleration is a vector. Addie, do you think you have it? The 2 is not a measurement. So you're just going to use these numbers. We only use measurements in determining of sig figs. Excellent. That is the correct answer. Now we're going to, I don't think we've checked this equation before. A is 2D over T squared. I'm going to check back. No, we have not. So let's check. A equals 2D over T squared. So Jack, what is the unit that we have for D? Good. We ignore the 2, right? Because there's no units attached to it. This is only with the units of the measurements. 2 is not a measurement. We ignore it. Janelle, what's the unit for T squared? Second squared. Is that what we expect to get? Done. See, that was an easy one. Because it right away gave you the right thing. All right, Olivia, can you read number 7 for us? This one wants you to get 2 things. Because we want 2 things, we're going to make a common givens list to use for the whole problem. Dakari, can you tell me something that we know in this question? So what units is acceleration in? Do I have any value that is meter per second squared? No. Okay, so what velocity are you being given? We have 4 types of velocities. We have a VI, we have a VF, we have a V bar, and we have a delta V. Which velocities do we have here? Okay, so which one's the VI? Okay, yes, so VI is 18.5 meters per second. That is the starting velocity or starting speed in this question. Josh, how about another given?
VF, 46.1 meters per second.
Good. Take my third given.
T 2.47 seconds.
Good. What's the unknown letter here? Yes, so for the first part of this, we want to find lowercase a. So we need an equation that has the VI, the VF, the T, and the A. Emily, do you see an equation that we can use for that? Yeah. Now, what is a change in V the same thing as, Cam?
Final velocity minus the initial velocity.
That's right. And I think if you've all done what I did on my reference table is I expanded that when we learned that equation. So you already see the VF and the VI and the T there? Yes? Good. Okay. So now it's already isolated for A. Let's do our substitution with units. So A would be 46.1 meters per second minus the 18.5 meters per second all over 2.47 seconds. Now, remember, I taught you to do the intermediate subtraction first and rewrite it. That way you can pay attention to the precision. So 46.1 minus 18.5 gives me a positive 27.6 meters per second. And then I would divide that by the time, and I can see now why I'm going to get 3 sig figs. Plus, I also see the direction on this answer. And Purnima, what is this answer with the units, the sig figs, and the direction? And the units? What did you say they were? You said meters per second? Okay, take a look. Meters per second are velocities, not accelerations. What are accelerations in, Ashley? Yeah, a meter per second or meter per second squared. Now, let's just check. Did we check that? Nope, we have not. So let's do the check of this over here. A is change in V over T. Savannah, what units do we have for the velocity change in the numerator? Good. Alex, what units do we have for time in the denominator? What units? Seconds. We don't care about any numbers at this point. All right, so let's take a look at what this does. Nick Rushford, what happens now? No. That would be a meter per second times a second. We would need the seconds to be in the opposite location. They're not. They're in the same location. They're both in the denominator. So Nick, what happens? What do you get? That's right. You get 2 seconds in the bottom. So that's a meter per second squared, which matches what we have here. And that checks. All right. Now, the second part of this question. What is the unknown, Jules? What's the unknown for the second part of this question? Distance, lowercase d. Now, listen carefully. I want you to find a way to do this that does not involve the answer we have for acceleration. And the reason I want you to do that is because if you use this acceleration and you made a mistake, the whole second part of this is wrong. So stick with the original givens, a VI, a VF, and a T to help you get a D, which means we have no acceleration to use. There's only one equation that doesn't have an acceleration. Caitlin, can you tell me what that equation is that doesn't involve acceleration? That's right. Which means we therefore need to know the average of these two speeds. How do you get the average of 2 speeds? Add them up and divide by 2. So let's go ahead and do that. Addie, can you tell me what that average speed is? That's right. You don't have to show how to get it. You just have to know how to get it. You add them up and you divide by 2. Now, the next thing we have to do is move this around for D. Jack, what is that equation for D going to look like? Correct. Now we can do our substitution with units. So the D is the 32.3 meters per second times the 2.47 seconds. And Janelle, what's that going to give us for this distance? Meters. There you go. And the check, I believe we did that previously in number 2. So I'm just going to say same as number 2. So you can go back to question 2 to look at that check step. All right. Okay. I'm going to shift around a little bit because Olivia, you just read the last one. I don't want you to have to read again. So let's start over here. Savannah, go ahead and read number 8 for us.
Rocket powered starts with the successful beginning response to acceleration. Like a rocket powered start is started at a speed of 444 meters per second in 1.8 seconds. There was no acceleration of just the second step.
Okay, so let me try to set the stage for you because I know you probably haven't seen these before. Have you seen bobsleds before? Okay, think of that as like the sled. Okay, it's not on ice, it's on a frictionless type of track. NASA uses these to test. It's one of the tests you have to pass if you want to go into space. You have to make sure that you can withstand, your body can physically withstand huge accelerations. You have to climb into one of these, and then there are rockets on the back, which all of a sudden, boom, shoot you off up to 444 meters per second, which is about 800 miles an hour. So you're going from 0 to 800 miles an hour in 1.8 seconds, which is kind of like what you feel when you go up into space and you lift off on a rocket pad, okay? They want to make sure you don't pass out. That's what they're trying to make sure, because if you pass out during the liftoff, we have a problem. Okay, so I want you to think about that because we've only circled 2 values. There is a third implied given about this person getting into the rocket-powered sled. So, Ashley, how about a given for this question? Right, because the sled can't be moving when you get into it, kind of like the airplane, right? The airplane can't be moving when you get onto it before it takes off. Okay, Purnima, another given. Okay, so that is the VF, 444 meters per second. And Cam, what's the third given? Good. Okay, what is our first unknown, Emily? So lowercase a. All right, Hia, I need an equation that I can use to get lowercase a with those givens. Good. All right, let's do our substitution with units. So that would be 444 meters per second minus 0 meters per second, all over 1.80 seconds. The 0 you can ignore, right? Because it drops out. Let's go ahead and get a final answer with units, sig figs, and direction, please. Fig, do you have it? And the direction? Yes, positive. Now, I'm not going to do the check because we did this check in number 7. So the check is same as number 7 that we just did previously. So let's now go to the second part of this question. Josh, what's our unknown in the second part of this question? D, lowercase d. All right, I need an equation that can be used to help us get D. But again, I don't want you to use A. Because if we messed up A, we didn't. But if we did, it would screw up this whole second half. Dakari, can you find an equation, therefore, that doesn't use A to help us get D? That's right. Which means we have to get the average of those 2 speeds. Olivia, what's the average of 0 and 444? That's right. Okay, Alex, move that equation around for D for me, please. What do you get?
D equals V bar times D.
That is correct. Okay, let's do our substitution with units. So that would be 222 meters per second times 1.80 seconds. And Nick Rushford, can you tell me what this answer is with proper sig figs? How many sig figs does this have because of the Atlantic rule right now? I need how many? 3. Very easy fix to make it 3. I want to count this way instead. There you go, 400 point meters. And the check is the same one that we did in number 2 yesterday. So I'm not going to repeat it, just for time's sake. Okay? We good so far? Let's keep going. All right, Nick Rennick, go ahead and read number 9 for us, please.
Light accelerates uniformly from x to a speed of 7.0 meters per second over a distance of 35.4 miles. Determine the acceleration of light.
All right. Jules, how about a given? Yeah, when we start from rest, our initial speed is 0 meters per second. Caitlin, how about another given? Good. Addie, what's my third given?
Distance equals 35.4 meters.
Very good. Jack, what's our unknown letter? Yes. Okay. Janelle, how about an equation that we can use for this? VI, VF, D, and A. So the time is the thing that we don't have in this question. So we don't want a time in it. No time. That's right. That's the only one that does not have time. Now we need to move it around for A. We need to move it around for A. We did something similar yesterday. I'm pretty sure. Yeah, we did. Number 4. We moved number 4 around for A, the same equation. You see it?
You just drop out the VI.
You can drop out the VI as well. I'm going to drop it out after I do the manipulation though. So Olivia, what did we get for A? Yes, because not every problem the VI is going to be 0. So I just want to make sure we can move that around. And Josh is right. That VI is going to drop out. So I'm going to ignore it. So A in this case would be 7.10 meters per second, which we're going to square. And we're going to divide by the quantity 2 times 35.4 meters. That's our substitution step. Now we're going to solve it. We'll need an answer with proper units, sig figs, and direction. So in the denominator, make sure you put a parenthesis in front of the 2 and after the 35.4, not one in between. Takari, do you think you have it?
0.712 meters per second.
Yeah. And what's the direction of this? Because acceleration is a vector. Correct. And the check, same as number 4. Same as number 4. So I'm not going to repeat it. All righty. We good so far? All right, let's keep going. The more practice we do, the easier these become. Josh, go ahead and read number 10.
The engineer is designing the runway for an airport. One of the planes that use the airport lowest acceleration rate is likely to be 3 meters per second squared. The lowest takeoff speed will be 65 meters per second, assuming these minimum meters.
Parameters.
What is the minimum allowed length for the runway?
Right, so it's an airplane taking off again. I think this is the third airplane question we've seen taking off. So Fig, how about a given?
Acceleration is 3 meters per second squared.
So lowercase a is our 3 meter per second squared. That's right. Tia, another given? That's right. It's got to start from rest. And Emily, my third given?
VF equals 65 meters per second.
That is correct. Cam, what is my unknown? D, a length is a distance. That's right. Okay, so now we have to go to the equation. Purnima, can you look at the reference table and tell me what equation would use those 4 letters only? There's no time given to us, so it can't have a T in it. That is correct. Now, this is a lot like the last problem, except I don't want A, I want the D. So when I move this around for D, it looks just like what I had, but switch the A and the D. So D would be VF squared minus VI squared over 2A. And something's going to drop out at this point. What's going to drop out? The VI, so that's going to go away, so just ignore that. So our substitution will look like D is 65 meters per second, which must get squared, all over 2 times 3 meter per second squared. What is 2 times 3? 6. So just do 65 squared divided by 6 on your calculator. One sig fig on this, right? Because of the acceleration. 65 squared divided by 6, rounded to one significant figure. Ashley, what's that going to give us? That's right, 700 meters without the decimal point. Now, I don't think we've checked this equation. I know we've checked it for A, but I don't think we've checked it for D before. Let's see, have we? No, we have not. So we're going to do the dimensional analysis on this one. We're going to check D equals VF squared minus VI squared over 2A. All right, Savannah, help me out. What is the unit we have for VF measurements? Good. And we're going to have to square that. Alex, what are my units for the VI measurements? Good. Yep, and we're going to put that with a square after it. Now, the 2 gets ignored because it's not a measurement. Nick Rushford, what are my units for acceleration? Good. Now, we follow order of operations, which means you have to square those things out first. So that's meters squared per second squared minus another number of meters squared per second squared all over meter per second squared. Now, combine your numerators. If I subtract a number of these minus another number of those, we get the same units on whatever those numbers are. You follow what I just did? Okay, so Nick Rennick, what happens now? So the second squareds cancel, and that square and that meter cancel. So do you see what hasn't canceled? One of those meters did not cancel, and that is what we expected. So that checks. Make sense? All right, let's go to number 11. Jules, go ahead and read this one for us. Did you circle those 3 things? Caitlin, how about a given? Good. Addie, another given? Oh, hold on one second.
Is it initial velocity?
That's right. And what does it mean if you come to a stop? Jack, what does that mean?
Final velocity is 0.
That's it. Okay, let's take our break. When we come back, we'll finish up this page and the next one.
This one.
Yes. Yep. Yeah, just grab another stool from back there.
No, I just got it.
Oh, go quickly. All right, let's pick up with number 11. So let's put our phones and electronics away, please. Number 11, Jack gave us the third and final given. So Janelle, what's our unknown here? D, very good. All right, Olivia, how about an equation to do this one? That's right. Let's move it around for D first. Dakari, what is that equation for distance going to look like?
D equals V bar times 2.
That's right. Now, I don't have V bar here, but we should be able to get it. I'm looking for the average of 22.4 and 0. Fig, what's the average of 22.4 and 0? That's right. All right, so now we can do our substitution with units. So 11.2 meters per second times 2.55 seconds. And now we can solve that for the distance with proper units and sig figs. There's no direction because distance is a scalar.
28.6 meters.
28.6 meters would be correct. Okay, that's the last one I'm going to present to you. Now let me explain to you what you're going to do for the rest of this period. You'll see that on page 25, there's still one more question. And on page 26, there are 4 more, right? Okay, I'm going to break you up into groups. I'll tell you who you're going to work with. And in your group, I'm going to tell you what question I want you to start with. Each group is going to start with a different question. And once you have finished that question, you're going to raise your hand and I'm going to come over and check your work. You're going to work as a group to get that question done. All right. Once you have finished that question, I want you to go do the others. There's 5 there total. So you can, again, work as a group to get the others done. What we will do is then I'm going to have, once we've gotten most of those done, everybody has at least gotten their question that was assigned, their priority question done. I'm going to pick one person from each group to come up and put their problem on the document camera. And then we're going to grade it. Okay. I'm going to grade it as if it's a test question. Now, when you do these, I want you to do the full guess check method. So I don't want you skipping the checks on these 5. You're working as a group to get those 5 done. All right. Do you follow what I'm saying? And there's no harm. You mess something up. I'd rather you mess it up now than on Monday's quiz. Because right now it's not going to cost you anything. We're all humble. I make mistakes on here too. And some of you have said, that's not right, Ms. Mimosa. Yes, you're correct. I goofed up. No problem. All right. So let me tell you who you're going to work with. Question 12. The priority is question 12 for, we have 18 of you and there's 5 questions. All right. So I'm going to put like 3 people, roughly 3 to 4 people in a group. So I'm going to have the 3 of you work on that question. Okay. That's your priority question. The priority question number 13 is for Josh, Fig, Hia, and Emily. The 4 of you are going to work on question 13. That is your priority question. And once you finish 13, go to the others. Priority 14 for the 3 of you. Okay. The priority is 15 for the 3 of you right there. And the priority is 16 for the 3 of you. Now, you 2 are over there because you're eating. As soon as you're done eating, I want you to go back to your seats and then you'll join the group. So Cam, when you come back, you're going to join the group with Purnima, Ashley, and Savannah. And Jules, as soon as you're done eating, you're going to join the group with Caitlin, Addie, and Jen. Okay? So, Savannah, which question did I say was your priority? 13? 14. Okay, so Cam, start working on 14 first. And then which one did I say was your priority? 16? Okay, so Jules, start with 16. But again, work together. So if you're getting stuck, actually, I don't have an issue. Do you guys have any food allergies? Jules, if you want to come over then and eat there, that's okay. That way you can work with them. Do you guys have any food allergies? Right there. Okay, so then come on over, Cam. You can eat there. That's not a, we have you sit over there in case there's food allergies, but if there aren't any, no worries. Okay. Yep, so talk to each other. So you 4 are going to work together. Okay, talk to each other. Talk to each other. If you want to get around the desk together, so like you're all around the same desk, that's okay too. You can move chairs. I don't care. Call me over when you finish your question. I'll check it before you go on to the others.
Yeah. I got a big number. Actually, no. 520 is 26. 162.
It's like the I equals square root
Did we already check this one? Yeah, I'll check.
You don't know who I'm going to pick to show their work on the camera. So make sure you're all talking together, checking it all out. And when your group feels like they are done with their assigned question, let me know. I'll come check it before you go on to the others.
Well, how many seconds? So then we can change it. So it's gonna be 1,060 squared, 160.
Yeah, the initial two. Because it goes as like. Doesn't change. So doesn't change the
So the other square.
I shall do.
Your group is done
No.
with your assigned one? Almost? Okay.
You guys are done? Yeah. We'll check yours. And yours is good. Just make sure that they don't match, okay? So we're doing 12. Okay, so the first thing you have to do is just substitute into this. So you're skipping a step. What are the units for VF? So you have to show that first. Meters per second, surround it with parentheses, and then put your square. And then you would show this, like you have. But you missed the very first part of it. So I'll show you. Right? Yes, that's correct. And then this step, yes, it's good. That's right. Okay, so just make sure that your two partners have the same things, and then you can go on to the next set of questions.
Yeah. No, it's not. It's the new one.
It's the square minus the x.
No, it's A equals EX squared over 2. Yeah. Yeah. Oh yeah, because I took out, I canceled out. Yeah.
Oh, yeah.
Yeah.
I have this one, but I just got that.
Yes. Yeah.
When you think you have your assigned problem done, let me know. I'll come check it. And then you'll go on to the others. So I'll check. Well, let's check.
And then, once that's done, then you can go back to 12 and then move on to the others.
I think I.
What are you listening at that number? Mhm.
So, square.
Right.
Yeah, because you divide it by
Yep.
meters.
That is correct. We're gonna put it in scientific square.
And then you put square.
That comes out, that comes out.
Correct.
Cancels out the.
Square. Okay.
So basically, it's just with.
Yeah, that's-
That's it. So now you wanna make sure that all three partners all have exactly the same one.
There's steps.
And then you're gonna go back to number 12, and then work through all the others. Anyone else have a problem done? Their problem done? I can come check it. You guys are ready. Who's am I gonna check? Whose paper? Check yours, okay. So I'll check yours, and then if yours is good, then you all have to check your paper against hers. Make sure. Beautiful, I'm gonna be perfect. Yep, so check against each other. Yep. That's fine, but you make sure you keep the negative sign out front and then you get the
Like last year, as much.
yeah, either way you can write it. I'm just saying it's. Another group that wants me to check it?
Let's just put.
I'll check yours and then I'll check your paper against hers. Okay. Which one are we doing? 14? Yeah.
Sorry.
It's okay. I have it. Okay, so that is not the equation you plug in. You want to solve for VI. You've solved for VI squared. How do you get VI by itself? Take the square root. So you have to do that first before you do your substitution.
It's gonna be I equals square root of VF squared minus 280.
And that VF squared minus 280 is all under the round. So
So
that's what you have to check as well. Okay?
Yeah. The answer should still be the same. You just put it.
Otherwise, if you solve for VI squared, you get meters squared per second squared, and your answer wasn't in meters squared per second squared. Okay, take out your earbud, please. Thank you. Again, once you finish the first problem, you're gonna go to do the others.
Just go over to VI squared. The square root cancels out the square. So it's just.
So 1365, 44, 42, and you get 30.8, 30.9. 30.9 seconds.
Yes.
Average.
Beautiful. So that's what you want to make sure everybody. It's the right. That's you got. You get that, and then you go back. Go back to because are you guys shy or sign problem? Almost like it stops.
That's what I thought. So is it final this year? And then official is 367. I had
That's
the
what
opposite.
I said that same.
So it's not the big number.
No, it
That's
is.
the
It's
next
just-
one.
It's, okay.
You're all done. Okay, you skipped one step on this check. The first thing you have to show me first is what are the units of BF before you square. Okay, so you have to choose for seconds, run under parentheses, and then hit the square outside. And then you go to that step.
Yeah.
Okay, you skip a step, let's skip it in the check. Okay, surround it with parentheses. You have units. Okay, so now you're gonna square them out, then you do your check. And it will go.
So then,
So, let me check the rest of it. I know what. Oh, you're missing units and you're.
yeah, it's like, I think I haven't tried as much as. Yeah, it's good.
That, no, I do not. You guys finish up that check. And then I'll check together to make sure all agree with the same thing. All right, and then go back to number 12. Or go on to 16 and go back to 12. But you want to get all the problems through 16 done, all right? You can work together as a group. Okay, how many sick picks do you need? So 1, 2, 3. Drop everything else, make those zeros. So it's only the first 3 minutes that you're gonna have to read out. Or put it in scientific notation, either way.
Yeah.
Yep.
I still not sure. We did.
I'm going to give you 10 more minutes. 10 more minutes to try to finish up those other questions, okay? Yeah, I got to get the G and the U first. Doesn't matter what order you put those in. Those don't matter the order, but the rest of it does.
I seriously wish we could do this check method. Like, good, it might have been a little different, but it's so good. I can't remember if we did it.
That's fine. Do you ever know how to do that? No. Okay, so then.
For question 12, the BI would be 0 because it starts not right.
Yeah.
Support the inside of this.
Yeah.
Yeah.
I think that there's only a changes. No. Yeah, no, it's not. We don't have a time. Would it be the same one? Yeah.
It's like the worst.
I hate them. Who creates that?
I might just do that. I might just drop the error.
Worst information. Oh, but it's gonna be a different.
Remember, you want to get all the way through 16.
So A equals BF.
And you can work as a group, so if you're getting stuck, talk to each other.
Over or over 2. Yeah. The whole is not
I have 17 timer.
I know. It annoys me. Yeah, like, I got picked on the 10.
Oh, it's sorry. This week. Acceleration.
Oh, it's because the active environment.
So,
Keep going, keep going. I'm only going to give you till 11:43 to try to get through 16, and then we're getting the groups up to the board or to the document camera. Not going to make you rewrite it.
yes.
I'm like still.
Yes, all-
Oh, yeah. I forgot to swear my stuff.
You already saw this, right?
Okay, so you
Yeah. There's a-
Whoa. Yeah. So you were right.
So, also.
Thank you. You have to subtract the I from the F and the divide the
That's not, that's. No, I don't think that's something.
Make sure you're working together, so help each other out. Help each other out.
You said,
I did get my
I did.
I'm just slow. Yes. I don't know why I'm so high. I don't think I'm just slow with these, but I'm just slow with
After,
my-
it's after, good.
Now it's done that.
Oh, yeah, and the house.
No. Yeah, what is the most?
Yeah.
Oh, so that's a bar. That's that. Yeah. Was that because, yeah.
No, Sophia.
Yeah, so it's already against speed and it's opposite. Okay, final, that was your stuff. Okay, I'm gonna, I think, you're gonna trust us. Yep, I'm gonna put my trust still. Yeah, okay. This, that is up and over. Well, we're not taking the same square. Like, it's not works. Yep. I can't take the zero out because I want to net steps. So it would just drop my half right. The F squared finds me, that's what over 2B. Don't forget to square your stuff.
All right, how about I'll give you one more minute and then we're going to start going over them, okay? And we'll double check that you have everything for every question. Correct, before we go on to work on homework.
Did you do 0 meters per second squared minus this? Okay. So there's 4 and 3, so we're not. Yeah. Negative 108.
All righty. So folks, I want you to go back in your packet to question 12 on page 25. Olivia, I'd like you to come up and put your solution on the screen for us, and everyone needs to check their work against this. Okay? So we're going to look at question 12. There we go. So you can see she has the 521 meters per second, the 0.840 meters, and acceleration indicated. We're firing a bullet, which means that the bullet starts from rest in the gun, right? It's not moving before it comes out. So the VI is 0 meters per second. The VF is 521 meters per second. And the D is 0.840 meters. The unknown is A. So the correct equation was VF squared equals VI squared plus 2AD. So A is VF squared minus VI squared over 2D. The VI is going to drop out. So we just take 521 meters per second. We square that quantity, and then we divide by 2 times 0.840 meters, giving us an answer of positive 162,000 meter per second squared. And then over here is the check. We start with meters per second. We have to square that and then divide by meters. You distribute the square first, which is meters squared per second squared divided by meters. So this meter cancels with that square, leaving us with meter per second squared, which checks. That would be, I'll tell you, I'm just going to write on your paper for a minute, if that's all right. Okay, so I'm going to show you how this gets graded. Each given on the test is worth a point. The correct unknown is a point. The correct equation is a point. The correct algebraic manipulation is a point. So 1, 2, 3, 4, 5, 6 points already. 1 point for the correct substitution. 1 point for the correct answer. 1 point for the correct sig figs on the answer. 1 point for having units everywhere. So 1 missing unit costs you that point. 1 point for the direction on that acceleration because it's a vector. And then you're going to get on the check step, you're going to get 1 point for plugging in meters per second for VF and 1 point for plugging in meters for D. And then you're going to get another point for showing how to get to meters per second squared correctly. So how many points is that total? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14 points for one question on a test or quiz. So Monday's quiz could be a 14-point quiz because it's a show work quiz. All right. Any questions about that? That's why your details are very important there. Okay. I would like Pia to come up and show us her solution, please, to number 13. And you can all check your work on it as well. By the way, the check in 13 is the same check as what we just had in number 12. Same one. All right. So in number 13, we have the 367 meters per second listed. We have the 0.0621 meters. We're looking for A. Now this one is the opposite of what the last one did. This one, the bullet was moving to start and it stops in that lump of clay. It embeds itself. That means it gets stuck there. So the VI is 367 meters per second. The VF is 0 meters per second. The D is 0.0621 meters. You're looking for A. Same equation, VF squared is VI squared plus 2AD. So A is VF squared minus VI squared over 2D. The VF drops out. So we have A is negative VI squared over 2D. So negative 367 meters per second. That quantity gets squared. And then we divide by 2 times 0.0621 meters. And that gives us an answer of negative 1,080,000 meter per second squared, or negative 1.08 times 10 to the 6 meter per second squared. Scientific notation is much better for something like that because it's such a big number. And then there's her check over there, which again is the same check that we had in the previous question. Very good. Any questions on number 13? Are you fixing your work as you see these? Good. All right. I would like Savannah to come up and show us her number 14, please. Okay, so number 14, we have the 290 meters marked. We have, okay, we should have also marked in the question, that's okay, the stop. And this is also a given value. You're looking for the speed. So she does have her D listed, 290 meters. Her A is negative 3.90 meter per second squared. The VF is 0 meters per second. Looking for VI. It's the same equation. VF squared is VI squared plus 2AD. So VI is the square root of VF squared minus 2AD. So we're missing one thing right here. You got to have your radical sign there as well. So we have our 0 meters per second, that quantity gets squared, minus 2 times negative 3.90 meter per second squared times 290 meters. And then you take the whole square root of that, giving us 47.6. This was just a speed, so we don't need that sign on there, 47.6 meters per second. Now let's check the work for the check step, because this is different. We have meters per second, which has to get squared, minus meter per second squared. There's no thing there. Meter per second squared times meters. So that gives us meter squared per second squared minus meter squared per second squared, all out under the radical. The subtraction gives us the square root of meter squared per second squared. Then you take the square root, which is meters per second. And now that's correct. Good. Any questions on that one? That one we had not done that type of manipulation before. So very good. Just make sure it's solved for VI, not VI squared. All right, number 15. Alex, I want you to come up and show us your solution to 15, please. 15 has 2 things that we're looking for. So this one's longer. We got to move, though, otherwise we're going to run out of time. Yeah, there we go. That's good. So, yeah, I know. So we have our 88.3 meters per second, the 1,365 meters. We're looking for A and T. So we start out with VI is 0 meters per second. VF is 88.3 meters per second. D is 1,365 meters. The unknown is A first. So VF squared is VI squared plus 2AD, or A is VF squared minus VI squared over 2D. He drops out the VI because that's 0. He plugs in over here, 88.3 meters per second. That amount gets squared, and he divides by 2 times 1,365 meters, which gives him positive 2.86 meters per second. And this is the same check as in number 13 and 12. So I'm not going to go over it again, but the check is here. Now, the second part is looking for, where's your unknown? Do you have an unknown listed for the second part? Your first part is finding A. I'll do it over here. The second part, the unknown, is D. So he's using V bar as D over T. Oh, not D. My mistake. You are correct, finding T. So that means T is D over V bar. So he averages these two things, and he found that his V bar with the same precision is 44.2 meters per second, which is correct. So the time is 1,365 meters over 44.2 meters per second, giving him 30.9 seconds, which is correct. Here is the check for this. T is D over V bar, which is meters divided by meters per second, which gives him seconds as the only remaining unit, which is correct. Okay, questions on 15? All right, Jules, come on up and show us number 16, please. Good. Oh, you even highlighted. So she's got her 112 meters per second, her 398 meters. We're looking for the acceleration. The VI is 0 meters per second. The VF is 112 meters per second. The D is 398 meters. You're looking for A. So VF squared is VI squared plus 2AD. So A is VF squared minus VI squared over 2D. The VI is 0, so that drops out. So we're doing 112 meters per second. That quantity squared all over 2 times 398 meters gives us positive 15.8 meters per second squared. And this is the same check as what we had in 12, 13, and 15, the first part. Very good. Any questions? All right, for Monday, you have to do the next 2 pages. 27 and 28. I'm going to revise my directions. Listen carefully. On page 27 and 28, you're going to do, it says use the guess method. You are. You'll check only on page 27. No checks on page 28. Okay, if you can do the checks on page 27, I'm assuming you can do them on page 28, but to save yourself a little bit of effort, you don't have to repeat them again. Okay? And that's your assignment for Monday. The rest of the packet is for Tuesday. But you can certainly start working on that over the weekend to make sure you're ready for Wednesday's tests. Okay. How are we doing? We got 1 minute until the bell rings.